All right, we are in geometry. We are in lesson 10-7. We're talking about tangents. So let's go ahead and do the date for today. The date today is the 18th of March, 2025. So as some vocabulary, if you have a line that touches the circle 2 times, that is known as a secant line. If the line touches only at one point, that is known as a tangent line. This is also going to be super helpful for later because some of the harder problems combine tangent lines with isosceles triangles. If you have a radius coming out from the center of the circle and you have another radius coming out from the center of the circle, this is 10-7. I can connect those two different points with a straight line, and that was supposed to connect them, but we did a really poor job there. Okay, I think I'm going to just have to try that one again. If I connect those 2 points, this is an isosceles triangle. Why? Eli, go for it. So with an isosceles, it can be nice and skinny. It can be really, really wide for the base. It doesn't matter the size of the base. There's another reason why this is an isosceles triangle. Go for it again, Eli. The 2 side lengths are the same length because what? Someone else. Why are these 2 side lengths the same? Evan. Yeah, why are they the same? Why is this line the same length as this line? They're both a radius. The 2 different radii have to be the same length. Therefore, these angles down here, this angle and this angle, have to be the same length. So I can say, usually you do like a little mark saying that those 2 are the same. Here, that one looks a little bit wonky. Those 2 are the same length. So be ready for that one. It will come and it will make it hard. So this is the type of problem that you'll be facing today, where you have a tangent line and a tangent line. It only touches at one point. You can't just have the line come right here and then stop. You have to have a tangent line that if it were to continue out, it would only touch at one point. That is the definition of a tangent line. So from here, you can do a few interesting things. So from the center, I can draw a radius to our point of tangency. If you do that, and this is the new thing that you're about to learn, this angle is 90 degrees. That's the one of the 3 things that you need to know that's brand new today. This angle has to be 90 degrees. That's thing 1. Thing number 2, you can divide this into 2 different triangles, and interesting facts come out of that. If you have 2 different triangles here, this length is the same. This length is the same. This angle was cut exactly in half, and I know that this side length is the same as this side length, meaning I have side, angle, side, and side, angle, side. They are congruent triangles. If I have congruent triangles, that means that all of their parts are also the same. It's also known as corresponding parts of congruent triangles are also congruent, which means that this length right here and this length right here, what? One's bigger than the other? What is it, Valentina? They're the same. They are congruent lengths. So I can say that this length and this length are the same. So if I say that this length right here is A and this length down here is B, you can say that A and B have the same length. You can do little tick marks there, right? That's the second thing that you're learning that's new today. The last thing is the relationship between this angle and this central angle. How do you find one from the other? Do you divide by 2 just like an inscribed angle? No, you don't. But I happen to know that if I have any quadrilateral, it always adds up to, let's see if you guys remember this one, the interior angles of every quadrilateral in 2D space adds up to, good yes, but no, 360. How do I know that? Because look at the triangles. This is a triangle. This is a triangle. Everyone nod your head. Yep, 2 different triangles. Okay, did you know that a triangle adds up to 180 degrees for their interior angles? Which means if I have 1 angle, 2 angles, 3 angles, those add up to 180. This angle, this angle, this angle add up to 180. If you combine those 2 angles over here, you multiply 180 by 2, and you say this entire thing adds up to 360 degrees. But wait, some interesting facts are this is 90 and this is 90, which mean 90 plus 90 add up to, everyone shouts out, 180. Evan whispered it or mouthed it. So from here, I know that These two angles here and here don't add up to 360 because I subtracted 180 from that. These two angles add up to 180. Very good. And that's what I'm going to say down here. We know that if I add the measure of angle A with the measure of angle B, they add up to 180, which means if I have an angle here, do 180 minus this angle to get the other angle, or vice versa. If I have this angle and I do 180 minus this angle, I will get the other angle. So far, so good. Let's see how these get applied to problems. All right. Problem number 1, I need to find the perimeter, and I have a tiny little piece that I don't know. How would I do this? I want to give some thinking time instead of just diving straight into this. Eli thinks he knows. Eli, I've called on you like twice already. Let me give these guys some thinking time. You're my backup if no one else can volunteer, including Valentina. I'm willing to get a volunteer from Valentina as well. You don't have to have the answer. You just need a step towards the right answer. And in geometry, a step towards the right answer means you know one thing. Like, I happen to know that there is a right angle. Perfect. Great. Maybe that'll help us. Maybe it won't. Give me any new information. I still see no hands. Eli, talk to me. Line through the middle like that? Okay. Now what? You are allowed to do that as long as I go through the point of tangency only to the center of the circle, which it missed a little bit. If I had gone from here to here, then it would be 90 degrees. But if I go to the other tip over here, it won't work. Good guess. All right. The theorem that it's really asking about is this one. I'm going to call it the ice cream cone theorem because it looks like an ice cream. Oh, I didn't mean to erase. It kind of looks like ice cream, and it always will be ice cream. These ones get a little bit wonky and sometimes don't look like ice cream. This length and this length have to be the same, which means this length and this length have to be the same. Do you mind lettering it in, please? So if this length is 6, this length is also 6. I meant to write that with not a dash line. Is 6. Well, let me give this a Felipe. Felipe, if this entire length is 16, but this length right here is 6, what must this new length over here be? Okay, so Felipe says 10. All right, well, let's give this to Melly. If this length right here is 10, what is this length right here? 10. It's also 10. And if this length right here is 10, Eli, and this length right here, what is this? This new one? 4. And Valentina, if this length is 4, what is this length over here? 4 as well. We have found the missing side length. So what I need to do is I need to add 14, 16, 6, and the missing side length of 4 to find the entire perimeter. Pretty straightforward, yeah. So I have 10, 14 and 16 add up to 30. 30 plus 10 is 40. So the answer here is 40. Another, number 2. I need to find this angle. I'm giving think time. Don't shout out the answer. If you think you have the answer, I want a quiet raised hand. That respects everyone else's thinking. I've got 3 hands. Let's go to Evan. Yeah, so this angle and this angle have to add up to 180. Therefore, that missing angle is 150. Done and done. What I should really be doing is saying, Valentina, Eli, did he get the right answer? Give him a thumbs up or a thumbs down? Yes. That validates the fact that you knew the answer as well. Number 3 and number 4 are hard. There's just no other way around it because they mix together an isosceles triangle with older theorems that are newer theorems that we just learned today. So stare at number 3. Any ideas on how to do number 3? Well, you can just give me one new piece of information, just like Evan did in the last problem. It's the same exact theorem. What's some new piece of information that would be useful? I see Eli's hand. I see Valentina's hand. Ellie's looking at her fingers. Okay, Melanie, you want to try it? Or can I give it to Valentina?
You give it to
Valentina, go for it.
Never mind, I don't know.
Can I give it to Eli? Oh, no. Evan, you're the last one that had your hand up. Oh, no. Felipe? No. Okay, well, I happen to know this angle right here.
150? No. 40?
It's one.
Yeah, you guys all knew that once I pointed it out. Any new information that would help is useful. 140. Yes. And what I have now is I know that this angle and this angle must be. Yes, how?
Because they're equal to each other because it's an isosceles triangle.
Yeah.
They're equal to 180 because it's a triangle.
Yeah, very good. I'm not sure if the mic heard you, so I'm going to repeat again. These two angles are the same because it's an isosceles triangle, and therefore, if they're the same, you can do 180 minus 140. So there's 40 degrees left to distribute between these two angles. 40 divided by 2 is that 20. So I can come down here and say this one up here is equal to 20 degrees. Very nice. I'm going to make an equation just for your note, just in case people are scared. I know that I'm going to have 140 plus two unknown angles, which I'm going to call x, x, and x. And that adds up to 180 because it's a triangle. And therefore, 140 plus 2x add up to 180. Subtracting 140 gives us 2x, which is equal to 40. And therefore, x is equal to 20. All right. Number 4. Ooh, this is the hardest one of them all because you can't even really do that same thing where you just jump from here to here anymore. This one is entirely brand new. It looks funky. And one thing that I'll note is that this line and this line are definitely not parallel, even though they might look like it. Oh my God, Eli already has an answer, but let me give everyone else time to think. Again, any new information is valid. Even if it seems trivial to you, it's probably the right way to do it because there's one really easy way to do this problem. And I think Eli already knows the first step. I haven't heard from Felipe yet or Melly yet. Makes me sad. Kind of want to give them this first and easiest of steps. I know, Eli. I want to give it to you. Have you really? Here, I'll give it to you, Eli, and then we'll move on to them. What is something that you know about this diagram that would be helpful?
The angle of the isosceles triangle is 30 because it's like on a flat line, so it's 180.
Oh, very, very good. This has to be 30 degrees because these two add up to the angle of a line, aka 180 degrees. That's something that's useful. All right, I need to call on either Melly or Felipe. I know this angle right there, specifically this angle right there. One of you two, tell me what it is and why.
90?
It is 90 degrees. Tell me why, Melly.
That's 180 divided by 90.
It's a good guess. It's not an inscribed angle. It's 90 degrees because it touches the circle one time. If you extend that line out, it only touches once. If it's a tangent line, then it has to be 90 degrees. Okay, those are also super useful. I know another thing that's useful that I knew Eli was going to do for his next step, so I'm trying to give it to someone else. I'd rather give it to here. I'm going to give it to Felipe. Eli, you're probably about to tell me this angle right here. Is that correct? Yes. Let's give that to Felipe instead. It is 30. Why?
It's the same than the other side.
Same as the other side because we have what sort of triangle? Isosceles. Very nice. Okay. Anyone can participate on this next one. Go for it, Eli.
90 plus 30 plus x is equal to.
Yeah, we didn't even need that angle. We're like, look at the picture. You guys all see this giant triangle right here? We have an angle, missing an angle. Can you set up an equation for me, Eli, just so that we have it down for our notes?
90 plus 30 plus x is equal to 180.
Cool. 90 and 30 add up to,
120.
if I subtract 120 on both sides, x is equal to.
60.
Very nice. All right. And this is the last one. This one, I throw it in here. It's kind of a tricky problem, but it's nothing really new that you've learned. The only thing that you need to know is this angle right here. It's 90, yeah. Oh, if I have a triangle that has a 90-degree angle and I'm trying to talk about its side length, what would be a useful theorem that we could use? Everyone shouts out. Pythagorean theorem. AKA what, Evan? There it is. And I happen to know that this, I'm going to call this entire length C, if that's cool with everyone else. So I'm going to go ahead and say that this length right here is C. Therefore, I have 12 squared plus 35 squared is equal to that C squared. All right, Melanie, 12 squared. Ooh, 35 squared. Not on our list. Our list only goes to 25. What do we do? Do it by hand. 35, that's 34. 35 by 35 is 5 times 5 is 25. 5 times 3 is 15, 16, 17. 0. 5 times 3 is 15. 3 times 3 is 9. With the 1 is 10. We add these together. We get 5, 2, 2, 1. 1, 2, 2, 5. So I'm going to say plus 1, 2, 2, 5 is equal to C squared. Adding these together gives us something. Valentina, help us. 1,369 is correct. And then finally we square root, and C is equal to, what could that be? I'm just going to use a calculator. You can do this by hand, but I prefer to not because that's going to take a bit of time. Let's see here. Can you guys, oh, you can't see that, but if I do it like that, randomly it works. Okay. Let's first check our 35 squared, which was 1225. Excellent. And I'm asking, what is the square root of 1369? Oh, that's nice. Let's come back over here. It's 37. Okay, so we know that C now is equal to 37. What is question mark? Yeah, why is it 37 minus 12 again? Yeah, radius is the same everywhere. If that's 12, that's also 12. This number minus this number gives us this number. So the correct answer for question mark, Valentina, is? All right, those are very typical problems that you'll be facing on the homework and the quiz and the test. Any questions on today's lesson? Before we do the fist of five, how well did you understand all 5 of those example questions? They're kind of tricky. I'm seeing a 4, a 5, a 5, and a 5, 4.5. Thank you, guys.